Hello everyone. In this video we're going to talk about the concept of p-value and how do we use p-values to make decisions on hypothesis testing. I want to remind you about the previous example that we did. And in that example we had this test, one-sided hypothesis testing, where we were checking whether the average volume of bottles is equal to 12.2 or it's more than 12.2. We ended up with this test score of 2.05, and because the alpha of the test, this level of significance of the test, was 0.01, our critical region is starting at 2.32, right? Because z of 0.01 is 2.32. And therefore, our test score is not in the critical region, and we failed to reject the null hypothesis. That was our decision. Now, you can clearly see that we're very close to the critical region. If the critical region was a little bit bigger, then we would have been in the critical region and we would have rejected the null hypothesis. So the decision that we're making is really sensitive to the choice of alpha. And here in this case, if the choice of alpha was, let's say, any larger number than 0.01, maybe 0.05, then we would have rejected the null hypothesis. So with that, for example, if the alpha was 0.05, our critical region would start at 1.64, and because the test score is more than 1.64, we would have rejected the null hypothesis. You can clearly see that the choice of alpha can ultimately influence our final conclusion about the test. Increasing alpha makes the critical region larger, which essentially makes it more likely to reject the null hypothesis. So now, with that introduction, what is the p-value? P-value is the smallest level of significance, basically smallest alpha, leading to rejection of the null hypothesis. So p-value is an alpha. P-value is a level of significance that greater than that value, we reject the null hypothesis. Smaller than that value, we fail to reject the null hypothesis. It's the smallest level of significance leading to rejection of the null hypothesis. Now, how do we calculate p-values? If the test is two-sided, this is how we calculate p-value. And if our test is one-sided of type more than, this is how we do it. And with less than, this is how we calculate the p-value. So we're going to show the p-value with the PV. And it's essentially calculating probabilities of z more than the z-score test stat. So once we calculate these p-values for any test, if it's a two-sided, one-sided, what do we do with that? We can make the decision using the p-value. We reject the null hypothesis if p-value is less than alpha. So alpha of your test is something that you decide for your test. It's the level of significance of your test. Common alpha values are, 0.05, 0.01, maybe 0.005, or 0.1. And if p-value ends up being less than the alpha of your test, you would reject the null hypothesis. And this is true for any hypothesis testing, two-sided, one-sided, anything. Once you calculate the p-value, you have to compare it with the alpha and make a decision. So what we're going to do is, for the same example that we had here, we're going to calculate the p-value, right? The example that we had with these two hypotheses, the standard deviation was 0.08, alpha of our test is 0.01, sample size 30. And if you remember, we calculated the test score before. Here it is. It's 2.05. Now, what is the p-value? First thing to look at is, well, our test is a one-sided test and the sign is greater than. So we go back here. For that type of a test, this is how you calculate the p-value. Probability of z greater than z-score. So let's calculate that. P-value is equal to probability of z greater than z-score. And that is p of z random variable being greater than 2.05. Now, we need to find this probability from the z table, normal distribution table. So if you remember, the normal distribution table is cumulative. So we have to change this to 1 minus probability of z less than 2.05 to do the job easier. And then you can read that from the normal table. Now here's the normal distribution table, and we're looking for probability of z less than 2.05. So we need to find the 2.05 on the z. So looking at the first column, this is 2.0 and this is 0.05, and you're looking at an intersection of them is 0.9798. So that is the probability of z less than 2.05. So that is equal to 1 minus roughly 0.979, which is approximately equal to 0.02, let's say. So that is our p-value. P-value of the test is 0.02. Now, how do we make a decision? We remember that. If the p-value is less than alpha, we reject the null hypothesis. In this case, p-value of 0.02 is not less than alpha because alpha is 0.01. All right? So, fail to reject the null hypothesis. Now, if you remember, this is the same decision that we came up with. We conclude the same outcome using the critical region method when we worked on this example originally. So here's that example, and we came up with to the same conclusion, fail to reject. So it is very important here to understand that using the p-value or using the critical region, both of them will result in the same conclusion. There are different methods of making these conclusions, and they should give you the same conclusion. If you end up with a different conclusion using any method than the other, that means you probably made a mistake somewhere. So that was p-value and how do we make a decision about a hypothesis testing using p-value.